Hi, so this is my narrated video for the one-way independent ANOVA test. These are my results. As you can see, it gave me some descriptives and then test of homogeneity of variance. Here is my Levine statistic. So it is 0.008, which is greater than 0.05, so my Levine test is not significant. So the Anova table right here shows the linear, cubic, and quadratic relationships. So the linear component tests whether the means increase across groups in a linear way. For the linear trend, the F ratio was 11.53, and that is significant at a 0.001 level of significance. So that we can say that as the opponent teams increase their playtime from nothing to a high amount of playtime, the number of injuries increased proportionately. We can also look at the quadratic trend. This tests whether the patterns of means is curvilinear. So if we look at the error bar graph chart right here, it suggests that the means can't be represented by a curve, so the F ratio for the quadratic trend is non-significant. These results right here are the Bonferroni test results tests that I conducted. So here are my descriptive statistics for that. As you can see, the Tonga had the highest mean, so it had like the highest cause of injuries. Here is my Levine's test. My significance is 0.008, which is greater than 0.05, or less than 0.05. Because it's less than 0.05, we don't meet the assumptions of homogeneity of variance. So next we can look at the test of between subjects effects. We're most interested in this independent variable team. Our value is 0.001, which is statistically significant. The partial eta squared value is 0.553, which means that 55.3% of the variance in the dependent variable. Numbers of injuries can be attributed to the independent variable team. So next we can look at the pairwise comparisons. So if you compare like Japan to Wales, there is not a statistically significant difference. Same thing with Japan and New Zealand. However, between Japan and Tonga, there is a statistically significant difference. And then we have the multiple comparisons table here, which is similar to the pairwise comparisons. It's just formatted a little bit differently, but the mean differences and the significant values are the same. And then we have a plot right here, which just shows how the number of injuries increase between these four teams. Next, so I wanted to go over the results that I got for the guided task on the handout, and this is my APA results for those. I wrote that a one-way ANOVA was performed to compare the number of injuries that 4 rugby teams caused. A one-way ANOVA test revealed that there was a significant difference in the number of injuries between at least 3 groups. So when initially looking at the questions, question 1 was, did Tonga cause more injuries than all of the other teams? And I said yes. The second one was, did Japan cause less injuries than Wales and New Zealand? I said yes again. And then the third question was, do Wales and New Zealand inflict about the same number of injuries? And I said yes again. And then these are my statistics to support those